Okay, welcome back. Let's talk about balancing oxidation reduction reactions. And so, first step we're going to have to do is break this into two half reactions, one where we have an oxidation occurring and one where we have a reduction occurring. So here we have zinc going from 0 to +2. So I'm going to pull that one out first. Zn2 plus is then, oh, sorry, this is Zn0. Why is this one 0? Well, since it's a solid element by itself, it has an oxidation state of 0. And it is going to Zn2 plus, and that is AQ. So this one lost 2 electrons, so I need 2 electrons here. And just as a note, this is my oxidation half reaction. Now, the next thing I'm going to look for is another element, and I see I have hydrogen by itself, so that must be my other half reaction. And I have H plus going to H2, and this is a gas, and this is AQ. And the first thing I have to do is balance the atoms. So I have 2 hydrogen atoms here. I need 2 hydrogen atoms over here. So I put a 2 there. And now that tells me I needed 2 electrons to make this compound. So I'm going to write my 2 electrons here. And so this is my reduction half reaction. So I balanced my 2 half reactions in terms of the same number of electrons being gained and lost. And I've balanced my atoms. So now I'm ready to add these together. And you'll notice that I'm keeping my 2 arrows right on top of each other. That will be very helpful if you do that. So my 2 electrons cancel here and here. So I'm going to have Zn solid plus 2H, and that came from HCl. So I'm going to go ahead and put the HCl back together. And I get Zn2 plus AQ plus H2 gas, and then I get Cl minus, and that's AQ. Now I have 2 Cl's here, so now I'm going to go through and balance the other atoms and make sure I have the same numbers of elements on each side. So I have 2 chlorines here, I only have 1 here, so I need to have a 2 there, and that balances all my atoms. So now I need to see if it balances in terms of charge. And I have plus 2 here and I have minus 2 here, and so charge balances. And my atoms balance. And my electrons balance. So my equation is balanced. Let's go ahead and try another one. Let's skip B and we'll do, let's do B. So we have I minus, and it's going to I3 minus. Ooh, we got a fractional one. Let's skip it. Let's do C. So I have AS2O3. I need to figure out the charge on that. And so this is going to be 2 times X plus 2 times -3 equals 0. So 2x minus 6 equals 0. So 2x equals 6, so x equals +3. So this is a +3. And then it's going, and I'm just going to erase that so I have room to work now that you've seen me work it out. And it's going to go to H3ASO4. There is a shortcut, and once you're good at this, you can use it, but just trust me. That's -8 plus 3 is +5, so this is +5. So it's going from +3 to +5. That means I need to have 2 electrons here to make my charges balance. And my other substance that's changing is nitrogen. So NO3 minus -6 -5, that's going to be +5. And I've got NO, and so that's -2, so that has to be +2. And so that's 3 electrons. So I have 2 electrons and 3 electrons. I have to have the same number of electrons transferred. So I'm going to multiply this one through by 3 and this one through by 2. So a 3 here, a 3 here, and that gives me 6 there. 6 here, 2 here, 2 here. Now I have the same number of electrons being transferred, and I can add them up. So I have 3 As2O3 plus 2 NO3 minus yields 3 H3ASO4 plus 2 NO. So I've balanced my electrons. Now I need to look at my atoms. So I have 3 here. Oh, I didn't balance my atoms here, so I have to go back and do that. So let's go ahead, and I needed a 2 here to balance my arsenic atoms. So that changes that to a 4 electron transfer. So I'm going to get rid of that 3, get rid of that, that, and that. Okay, so 4 and 3. So I have to go to 12. So I'm going to multiply this through by 3. And that makes that 6, and that makes that 12. I'm going to multiply here by 4, so that makes that 12, 4, and 4. Okay, so that's good. This needs to be a 4. That needs to be a 6. And that needs to be a 4. So now let's look at our atoms. So I have 6 arsenics and I have 6 arsenics. I have oxygen on lots of places. And I have not yet balanced hydrogens, and I'm just going to add hydrogen ions on that side. I have 4 nitrogens and 4 nitrogens. So now let's count up our oxygen atoms. And so I have 24 plus 4 is 28 on this side. And I have 9 plus 12 is 21. Okay. So I'm going to add water to balance out my oxygens. So to balance oxygen, I add water. So I need 7 water molecules over here, and that'll give me 28. Now let's look at hydrogen. And so here I have 14 hydrogen atoms. Here I have 18. So I need more over here. So I'm going to add hydrogen ions, and I need to add 4 hydrogen ions. Oh, on the other side. So I need them over here, plus 4 H's, and that gives me 18. So now we've got our atoms balanced. Now let's look at charge. We have a positive 4 and a minus 4, so that gives me a 0 charge on here. And I have a 0 charge on here, so my charge is balanced as well. So when we get to balancing oxidation reactions, this redox half reactions, this one will make more sense. But after we balance for electrons, when we're balancing for atoms, if we need oxygen, you add water. If we need hydrogen ions, we just add hydrogen ions if we're in an acidic or not stated solution. We'll talk about basic balancing later. Basic is a little harder. Oh, you can't even see all that, can you? So if you need to add oxygen, you're going to add water. If you're going to need to add hydrogen ions, you just add hydrogen ions. And basic will be its own discussion all on its own. In fact, we may just skip basic. Okay, so thanks for watching.